Give me all of your lies, 'cause you're my demon in disguise. I learned to love the cage you keep me in, but the walls keep closing in. And I don't wanna die, but your poison feels so right. But do I want you when you're bad for me? A perfect storm, a beautiful catastrophe.
Hello everybody, we're here in Vysoké Mýto, Czech Republic, and today we're going to be showing you JMB Aircraft factory. My name is Matej. I'm very happy that the guys joined me today, and let's hop inside and let's see the beauty. So we are now standing in just final assembly of JMB Aircraft. If I would have to put it into perspective, this is about 30% of the whole production that we have. So to be completely clear, when the fuselage and the tail parts and the wings are ready and they're painted, that's the moment when they come here. This is very unique because you will not see this with any other manufacturer. We have constantly about 140 planes in a production line, which is truly amazing. Yeah. That is a lot. And the fascinating thing about each of this plane is that every plane has a customer. We never produce a plane without a customer. And every of these planes is fully customized. So each line on these planes were discussed with the customers. We have something like design meeting. Then I will show you later on, we have a design room. We copied the Rolls-Royce kind of thing. Okay. So when you purchase an aircraft from JMB, there's flight trainings and everything. This is what we do in Belgium. But then you come here and you select the colors, you select the interior, the exterior colors, and you select the avionics, of course, for your aircraft. And this is why we're quite big in this industry, because it's 2025 and people love this. People want their airplane, they want to have emotion towards the thing. So what I always say is that the plane will give you feeling that if you have your first car, then you're always parking it on a parking lot. You go from the car, you click the keys, and you always have that last look around your shoulder. Yeah. So this is the feeling we want you to get with your plane.
It's amazing. And so here it's very much like an assembly line. You go piece by piece, part by part, until eventually...
Exactly. So the funny thing is that like JMB Aircraft is a growing company. When we first started to do sketches of this building, how it's going to look like, so the final assembly was originally made for 8 airplanes.
Wow.
Yeah. And if you
you look now, it's
yeah, we're a little bit stuck here. So I think currently we would be looking at 22 to 25 planes just here in a final assembly.
These are like all the parameters that you can customize?
Exactly. So it's very hard to produce an airplane. So to produce one airplane, it's 3,500 hours of man work. 600 hours is just to paint the aircraft. So because the big enemy of ours is the weight, because the plane can fly even if it weighs more. You will not feel too much different if it's a couple kilos. But the problem is the regulations. We need to be extremely light. Yes. And then if you imagine you have a plane that is flying 200 knots, and can pull 4 Gs, is capable of, has autopilot inside, full glass cockpit, and still your empty weight is 380 kilos. Yeah. So this is crazy. And this is good comparison because the most of the production line is a VL3 with a Rotax. This is an Austrian producer of the aviation engines. And the Rotax 916, that's how they call the engine, has 160 horsepower. And you will say like, okay, so 160 horsepower compared to like a Porsche or something. Yeah, it's not that much. But imagine if you have, I don't know, Volkswagen Passat. So with a 2-liter diesel, it will have 150 horsepower or 160 horsepower. And like you can imagine how it goes, how it drives, the acceleration and everything. And now if you say that the car has 2 tons, and this has 380 kilos. Yeah.
You see why these can go 200 knots.
Exactly. This pulls the airplane like really, really fast.
Yeah. And so the VL3 right now is a flagship model.
Yeah, VL3 is a flagship model. I would say, like, of course, there's the bigger number of the orders is for the VL3. We have the Phoenix, which is a motor glider. You're also available to customize it and stuff like that. But there we are limited by the production, and we can produce between 8 to 12 units in a year. So we are filled there also. But the Phoenix motor glider, we're basically the only producer in the world where today currently you can buy a brand new customized motor glider. Wow. So it's like you doesn't have to check for pre-owned planes where you don't have a warranties, where you don't know anything about the plane. Then we have a SV4, which is like a replica of Stampe.
Like a biplane, yeah.
Exactly. This is my favorite one of them.
Will we get to see it?
We don't have a unit in here, but there should be a unit on the other side of airport, so I'm happy to show you.
Here you show them their plane. Mm-hmm. Is there any other processes so they get to design the livery, the paint job?
Yep. So when you order an airplane, so the first thing is that we will ask you for a deposit, and we will start to make the composite work of your aircraft, the fuselage, the tail parts, the wings, and stuff like that. And then we basically invite you for a design meeting. This is what wives of our customers really enjoy. Yeah. I will show you the design room in a minute. And there you will select your design. Then you're entering the finishing and painting department. There we make the plane as beautiful as possible. The fascinating thing on this is that you can see it's like the designs are perfect. The lines are perfect. There's a lot of details. And I told you previously that we are all about of saving the weight. So the interesting thing is that this is painted next to each other. And because when we paint the colors next to each other, so when the airplane is not painted, we'll put a tape in a line where we want, we'll hide the rest, and we'll paint this white. Then when we put another tape and we paint this one red, then we brush it under the water, so there's no differences between the surfaces. And then we put a clear coat over it, so we can put a warranty, because we have a warranty on you buy in the European Union. You need 2 years of warranty on the product, but of course we need the plane to look good even after 10 years or something. So when we paint the colors next to each other, we'll save about 1.5 kilo of paint. Wow. And you say, yeah, but you will be like, okay, 1.5 kilo, it's not maybe that much.
It's a lot.
It's a lot, because 1.5 kilo.
Little sums, little by little.
Exactly. But for the sales perspective, 1.5 kilo is your second G3X FS screen, okay, which we can sell you, okay, where we make a profit.
Perfect.
And you're more happy because you have more stuff in your plane.
Exactly.
It's so amazing, like a monocoque carbon fuselage, one piece?
Yes, wow. Yes. It's one piece. So let's say you do 2 halves together, and then you stick them together at the last moment. There's basically if you want to know the technical side of it, we use 3 composite materials. We use Kevlar, we use carbon, and we use glass fiber. And the VL3 is amazing in one thing. Of course, we invent a lot of things, but also, and this is like the check a little bit of thinking. Why would I invent something that has already been invented? If you look at the shape of a VL3, yeah, it might look a little bit like a Lancer. This is like this was an American producer of airplanes. And the airplanes are known because they're super fast. Yeah. And we copied the shape, or the guys that originally made the design in Czech Republic. But what they did better is that they made it all composite and made it all extremely light. So the airplane is capable to fly high speed, but still is with the regulations in Europe. For example, the wings, I'll show you them in a minute. They are all made from glass fiber. So the wing is fully glass fiber, not carbon, not Kevlar, but glass fiber. And the reason for this is, imagine in your head a picture of Swiss Alps, and there's a glider gliding around there. You can see that their wings are like this, they're tilted. And they are also made from glass fiber, because glass fiber is one of few composite materials which is flexible. And when you have this in the wings, and the big issue is the turbulences, the wings are tiny bit flexible, so you have more comfort. And the wings will be flexible when you hit like a turbulence. So this is always this is always a copy from the technology of the gliders. If you look at the gear system, it's a copy of Cessna's gear system, because it works, it's perfect.
It's proven.
Yeah.
And so when it comes to the other parts, for example, the canopy, the seats, are those also made in-house, or what's...
It's made in house. So the thing is that this is one of the funny things. Like it looks like a serial production. If I would show you 8 VL3s finished with interior and everything, you would be like, yeah, this is serial production. It's never serial production.
In-house.
So the customers, they will customize the stitching, the leather or Alcantara or whatever they want. But the fun thing is that like if you purchase an airplane, there's gonna be like stitching, and the ladies, when they were doing the stitchings, they always did something a little bit different. You know, they try to reach the perfection, but somewhere will be a little bit of tiny difference between sides. And this is what people love, because then even if somebody has the same specification, which doesn't happen, but if you have 2 exactly the same planes, the people will always sit in it and they will be like, oh, this is my plane.
Exactly.
Because I remember this little detail. This is what you have with customized cars.
Yeah.
So I think the customization is a big point of why people buy these things.
All right. So the whole plane is what's. I think it's easier to say what's not made in house and what's made here.
Okay. So I would say that's the of course the engine.
Yeah.
That's the avionics.
Yeah.
And of course the metal parts and the gear system, the hydraulic pumps and stuff like that we buy. Otherwise, the controls of the aircraft, the interior, even this central tunnel is made from glass fiber. We have a mold for it, and we work with this in house.
Very cool.
So what we see here is basically a, well, this one has an engine, but it doesn't matter. So this is like mostly built here in house.
Exactly. Exactly. That's the thing. How you can survive if you have if you buy the things. It's to if you buy like the big things. If you buy the wings from somewhere else. If you buy the fuselages from somewhere else, like somebody will produce it for you. The outsourcing. Then if you have production like this, then it's very complicated to manage the cash flow. If you make everything in-house, then basically you can control the whole business. You can never be surprised by anybody. If we want tomorrow to produce 30 fuselages, we're able to do it. We don't have to call somebody and ask them, oh, do you have a capacity in your production? So we just have it.
Vertical integration.
Exactly. So we're in design room, and like if we say customizing the airplane, we just don't speak about the avionics. We speak about like every detail. So we'll start usually with the exterior, because that's for a lot of people, like let's say the easier part where they know what they want. How we do it with exteriors is that we have 700 units flying out there already in Europe. So in Europe, the VL3, just so you can imagine, if you're a plane owner, if you have a 916 VL3, you land at any kind of airport in Zelensee, in Lido, in Venice, in Portorož, wherever you want, and people will come to you and say like, oh damn, you have a 916, that's cool, can I have a look? And it brings attention, because it's like a Ferrari between like the LSA light sport aircraft. So that's what people like. So we usually start with exterior, and we had to, in a certain point, it's about 6 years ago, we had to segregate the designs that we offer for each engine model, because we just don't want to, because then everybody would be for half a year, everybody would be getting this, for half a year, everybody would be getting this, like the new things. Like the automotive industry, they will always like, I don't know, Porsche will start to do like some certain matte gray or something, and everybody is getting it, you know? So what we did is that we have limited the designs that you can only get with a certain engine on your aircraft. And so, for example, we sold 912 with 100 horsepower. We sold a 915 Rotax with 141 horsepower, and we sold we sell most of the time now 916 with 160 horsepower. And people who are buying the 916 currently, and it's expensive, they want to show that it's 916. And of course, the small logo 916 on a cowl link is not enough. Yeah. It's not enough. So we had to do like the special 916 limited design. We also did this for a 915. And basically, the idea of this is that if you buy, for example, 912 with 100 horsepower, you can never get a limited 916. All right. But if you buy a 916, the top of the top, and you like a design that is on 912, you can get it. You know.
Okay.
So it's just like, so there's like no cheating. Yeah. So you can see 916 with the limited 915 design. So you can see that, but you never see a lower version 915 with the limited 916.
Right.
So that's basically, that's the pixel design that you just see the tail there. So you know these sextagons. So they're just like basically they're just like the tail, the red one, the red and blue. So the whole plane is with like this scheme. And what we will allow you, of course, that like you will not like the blue, you will not like the white, you will not like the red, and you don't want so much of that scheme on the tail. You only want maybe 3 these sextagons. We'll do it for you. That's not a problem. But we'll just follow the nature of the scheme, so it's still visible. It's a 916. That's what you do here. But for example, this blue plane, this November 655 Victor Lima, it's a 916.
Right.
But this chest design that you see on all the older pictures, it's a limited 915 design. But the customer was allowed to get this design because he likes it. But the design is, let's say, a downgrade from the limited 916. So it's still beautiful. I love the design. This is one of my favorite ones with this turquoise color and a Porsche dark gray. But he was able to do this. And this is also like a nice thing from the marketing. The colors that we use, this is just a basic selection, okay? We have much more. This is basically unlimited. We work with the composite materials. We cannot get you, like the plane cannot be full dark, like let's say full black.
Right.
But the darkest color that we use and it's not affecting the composite structure or something like that, is a Porsche dark gray. That's what you're gonna see the people like it. So they go for and it's exactly the color of a Porsche dark gray. Why we have it like this is that it's on a magnet.
Oh, wow.
You will take the color, and here it's hidden, and this is Aston Martin Sunburst Yellow. So this is exactly the Aston Martin color that you're getting on your, exactly the same color.
Wow.
So people come here and they're like, oh, I have a blue Ferrari. And we're like, no problem. You want your plane to match the Ferrari? And they're like, yeah, sure. So one of these blue colors will be blue Ferrari. Why we have it hidden on the other side, why we don't print it on a front side, is that it happened to us. We had it other way around, but what happened to us is that like there's, I don't know, I will just choose one of these, and it will be, for example, okay, so this is beautiful color, right? But people will turn it, and it's a Honda, and they're like, oh, I don't want a Honda.
Yeah.
And we're like, no, you like the color,
Yeah,
so let's work with it. So people will start with exterior design. Then we will match the prop tips on the aircraft. So we have it like this, and we can paint this also in a color of matching your plane. Wow. So that's like another level, yeah. Then we match the wheels
Those
of the
are
aircraft.
the rims of the landing.
Exactly.
Okay.
Exactly. Those are the wheels, and then basically from the exterior, I believe this is it. Of course, the spinner of the airplane and stuff like that. And then the fun part starts. Then we start to work with the interior. All right. So there's a couple options for the colors. This is just the stitching. All right.
And it's all made in-house.
It's all made in-house. Yeah. Yeah. We'll show you that today. So this is just the options for stitching. If you want more, we can find more. But there's like really fancy colors. There's like luxurious colors, and we work with this.
It's amazing.
So that's basically it. We work with 7. Let's say our designer, he selected like the 7 most famous leathers colors that we work with. So they should be. It's a BMW brown. There's a black. There's a red. They have a names. I'm just not a designer, so I don't know everything. And if you don't like the leather, you can have Alcantara. So the Alcantara, it's not the ideal for the hot surroundings. If you fly the plane in Italy, you will sweat in Alcantara a little bit. The leather will be your thing. Okay. So that's basically it. And when you have the seats, you can have a mixture also. We have lines of the seats. We have 6 lines of the seats, and you can choose, like, it can be a mixture. Like part of it can be leather, part of it can be Alcantara. If you don't like any of the options of the leather, you can, and you have like, I don't know, you have in your house, you have a beautiful sofa from which you bought in South America, and it was made by a cow that only lives in South America. We can do it. We can get you exactly the same color or something. The only thing is a little bit more expensive because we only need a couple meters squared for interior, but we need to buy the whole cow. Yeah. So that's basically, and I'm speaking about the leather. We don't kill the cows in here. Yeah. And then when you're finished with this, then there's a last touch, and we'll give you basically a selection of the seat belts that you want.
Oh, so everything.
There's everything. There's everything. So there's the side tunnels. This is how the drawings of the planes, this is what you're working with it. So this is the technical drawings.
Yeah.
This is the technical drawings we need to describe like on each part. And then just like the production knows what to do with it because it's clear for them.
Excellent.
Yeah.
So cool.
Yeah. It's a nice experience.
It is.
We don't sell airplanes. The airplane is good. There's 700 units produced. There's 850 in total sold. There's gonna be serial number 1000 coming in soon.
Wow.
So the airplane is good. Like it's working. It's beautiful. It's the fastest. The only thing that you need to sell on the top of this, because we know we have a good plane. Yeah. So I like if somebody comes through the door here and they're looking to purchase a plane,
yeah.
It's easy. It's the best is if they come with their wife and you can visually see that the guy knows what he wants, and his wife is like, oh, he's buying an airplane now instead of Lamborghini. That's a little bit tired. But the funny thing is that what we do is that at a certain point, when we train you for your aircraft, we also separate you from your wife, and we will put her with the company pilot, with the instructor, and we will teach her that there's a level button on an autopilot. If your husband ever gets feeling sick or something, you press the blue button, and the plane will fly in with the leveled wings and not descend, and it will just fly in level. Then we show the wife how to change the squawk on transponder to emergency frequency. We how to call on a radio a little bit, and how to press a smart glide, because every plane has a function that if you have an engine out and you're busy with orientation, navigation, and stuff like that, you press the red button and the airplane automatically, even without the engine, leads you above the nearest airport. It has a GPS inside, it has a maps, so it will select the best glide ratio, and it will lead you above the nearest airport. Then it starts to beep, and then you do your no engine landing, but this is easy because the airplane is very light, so it's actually like gliding pretty much good. Like the glide ratio is 14:1. So if you lose 1 kilometer in altitude, you will glide 14. So if you fly in, let's say, flight level 9 or 0, which is 9,000 feet, this is 3 kilometers, a little bit more, then you'll be 3 times 14. So it's 42 gliding distance around you. And this gives you options when to land.
Right.
But this doesn't basically happen. The engines that we use are like extremely reliable. There's a video on YouTube with one engine that failed, but the engine had thousands of hours, and it was like on an old plane. But I would say in last 2.5 years, we had no single engine failure. We had a loss of power. You know, your turbo, the plane has turbo, so the turbo can stop to work or something. Yeah. But then you're still left with 80 horsepower, and this will not give you any good glide performance or something like that. But it will keep you in the air.
Yeah.
So we're now standing in Avionics shop. So all the instrument panels are also, when you purchase an airplane, we work this with you. We select which instrument will be, so it's more flexible. There's certain things are standard on the panels, but of course you can customize the positions and everything. But we always keep like the plane is of course the thing that you have feelings and emotions towards to, but it's also going to be think that, and this happens more and more, the people will buy an airplane from us, then the new engine comes out, and in 2 years they will sell their own old one, and they will purchase a new one. And so we're guiding the people in a way where the plane still keeps the value. So to not do anything like extremely like not resell it, but for the future. Right. So we work mostly with Garmin Avionics. The Garmin suite is the easiest for it. There's it's something like for example, Apple devices, they communicate between each other very good. You know, your iPad communicates with your iPhone and with your MacBook and everything. So this is what Garmin offers. It's a whole like whole environment of this. Right. So we use autopilots from Garmin. Every VL3 has an autopilot. This is kind of a safety feature also. Right. So every new plane will have an autopilot, and you want to fly with the autopilot. So how you can have, that's the good thing about our planes. You can fly with the VL3 and you can have all the fun and everything. It's very responsive. You'll see that tomorrow. It's fun to fly. But then if you're flying longer distance, you climb out of the airport, you're 1,500 feet, engage the autopilot, and basically, I don't know, we flew from near Brussels to La Baule, which is southwest of France. and I engaged the autopilot at 1500 feet after the takeoff under TMA of Brussels, and I didn't touch the controls until I was doing downwind approach in the south of France. You just control the autopilot. The another thing, it's like I sometimes speak too much about, like, from aviation point of view. I will try to be a little bit easy on this. So when you fly the aircraft anywhere, you fly via waypoints. It's like something you can compare it if you're driving with your Google Maps. So you see streets, so there's something like this in aviation. So there's points and you fly from point to point to point. And you have like aviation maps, like you have a Google Maps for your car, which will give you navigation. You have aviation maps. You have applications for this. It's a Sky Demon. There's ForeFlight and stuff like that. You will select your route before you fly, where you want to fly, and then via Bluetooth, you push it to the plane. Yeah, and then when you engage autopilot and select the nav mode, the plane will automatically turn on the points for you, so you don't have to literally do everything. You just listen to your radio and monitor the aircraft.
Amazing.
So,
are all the panels fully customizable, or with this do you guys offer like a standardization?
oh yes, there's a standard. So VL3 is, I would say, like a luxurious product, and we don't want to deliver VL3s with just analog instruments. This doesn't make sense. It would be, it's not even, you're cruising so fast that you need a certain like overlook of the situation. You need to see at least your artificial horizon and stuff like that. So you always, if you for example look on this panel, so this side, which is the G3X, there's a Avionics switch, master switch, and stuff like that. This is always there, and your gear, of course. This is always there. This is an option. If you don't want this, people will put a mount for their tablet there, and they just have a tablet. There's a certain set of lights. If your country requires more lights or something, or you want to fly during the night, you want to fly IFR. We also do it. And basically, if you go for the basic configuration, you will get the G3X on the left side. This is very close to the basic configuration. There's only option here is extra the manual flaps. We can do this is electric, and we can do manual. But otherwise, you'll get analog instruments. This is safety. But you also see your speed and everything in a G3X. But if you would lose your G3X, you still have analog. You have compass, and this is your transponder, and this is your radio. So you always have always have
something.
Yeah, you have nice equipment already in a base price. Yeah. Also, like the feature that every plane produced by JMB Aircraft, that's the Phoenix, SV4, VL3s, or the Evo, you always have a parachute. We're always about the safety. So there's a ton of features on the airplane. There's like passive features that prevent you from doing something stupid, to the active features like angle of attack. It gives you warning if you're flying in much steep angle or something. And there's like even there's details on the aircraft that will prevent you from, for example, stalling the aircraft, because all that JMB is about is, of course, and this is a little bit of cliche, but it's a safety. But in aviation, this is even like more added value to this, because basically, if you have one single crash, it brings a bad reputation to the brand. Like people will be scared. Yeah. So that's why we, for example, have, when you purchase an aircraft, you will fly to Belgium, to Amougis, to our flight school, and we have a full-scale simulator. We cut the fuselage, we have 180-degree simulator, and we will teach you when to pull parachute, when to not pull the parachute, which are the situation, how to do the emergency, and basically we'll just learn the people that even in critical situation, this is the price of the aircraft, and this is the price of my life. Exactly. Not like this. Yes. So that's what we are trying to figure out.
Is it compulsory to do the training? Like, let's say that I'm a really experienced GA pilot and I want to get one of these. Like, can I just like not get it? Can I just get it outside the factory and like just fly it?
Like you might be, if you're really experienced on light airplanes, you should be able to. But we would never give you the keys. So you will fly.
Company policy.
It's company policy. You need to do a simulator training. And you need to do the at least like 5 hours with our company pilot. And 5 hours, you can do it. But basically, the people fly between 8 to 15 to get really comfortable. Okay. So the airplane it's easy to fly. It's not hard. But you fly, we get a lot of like ultralight pilots. And this is not an ultralight. You're like the biggest problem for me when I started to fly the VL3 was to slow down above the airport. Yeah. So even if you go full throttle idle, it just continues to fly. It just doesn't want to slow down for your gear extension and everything. Yeah. So we teach people that all in the plane happens fast. So it's like if you speak about kilometers, let's say for the viewers, if they can experience it a little bit better, you're approaching the airport and you're still doing 240, 250 kilometers, and then in about 15 seconds you need to slow down to 150 kilometers, which is a limit for the gear extension, and then the gear will extend, and then you go 141 kilometers, and then you do your flaps and everything, and then you need to follow the speeds. So this is for, let's say, older guys. You need a couple hours to practice this, so you're good. If you're young and if you have like 40, 50 hours and you will immediately jump on a VL3, it will feel natural for you. So it will feel like, okay, you can do this, because there's a lot of things. You have basically, if you look up the videos of a VL3 pilots, bye-bye. If you look at the videos of VL3 pilots online, you will see them doing checklists. This is something that you don't see in LSA industry. We have checklists. I fly with a kneeboard, and before we jump in a plane, you'll see that tomorrow I go through full checklist. In a lot of LSA planes, which are not complicated, fixed gear, easy rotax, chuck, flaps maybe, and then we go in. Even if you don't put the flaps, you will just climb somehow out. But with the VL3, you really follow the rules. So
Yeah, there we go.
So you need to check the gears down. This is hydraulic pump. We will switch the avionics on. And this is like this is a plane that shall be finished in less than 2 weeks. Wow. So all you see here on the left side, as I said, is a standard. Now 2 garments will pop on. There's an O2 silver button. There's a generator of the oxygen. If you fly in a high altitude, in a tail, there's a generator.
And this is pressurized.
And it's not pressurized. You have cannulas that goes through here, and you stick it into your nose. It's like no non-comfort. You have it. You don't even have it in your nose. You have it in front. It gives you the flow, but you never need to refill the bottles. The bottle, the generator will always generate and filter the oxygen. So it gives you like this pumping. It's not calibrated yet, and you see it's like a little bit tilted since it's still in production. But yeah, there's a camera. They just need to put it straight, and of course, what you do last minute. So you can always see your gear. You can see your comms. There's 2 radios in this aircraft. There's oil bar, oil pressure, and everything. You will see that working tomorrow when we fly the other plane. So this is basically the magic behind this. And there's your propeller. Yeah. We have adjustable propeller.
Yeah,
you adjust with a variable pitch. So this is. And here you can see, like, if you get a ultralight pilot, and you give him manage the prop, manage the gear, manage the flaps, it might be a little bit of challenge, but everybody will learn it. Yeah.
How long does the tank last for if you fly above, like, let's say 12,000?
So it's 70 liters and 70 liters in each wing, so 140 liters on board. And I would say if you set very high altitude, like 12,000 feet, that's in Europe, usually pilots fly at like 9 or 5, so 9,500 feet. If you manage, if you want to fly fast and a little bit in an eco mode, but like not like you want to get somewhere, so you'll be doing 180, 185 knots. Your ground speed will be basically more than 300 kilometers, way more. And you will be up there for, let's say, 4.5 hours. The consumption should be around 25 liters. That's what you want to see. That's the number that is ideal. If you release, like literally, like you can fly with a 916 with this engine, the strongest one, you can fly and you can consume 14 liters, 13 liters, but you'll be hell slow. And the thing is that like the ideal jump for me personally, and I'm not the 50 years old guy, I'm 30. But for me, it's ideal like 2 hours, 45 minutes. And this gets you from Prague to Brussels. Right. So you will be even faster. You'll do like 2 hours, 20 minutes-ish.
Yes, it's like Atlanta to New York, something like that, yeah.
Yeah, it is, but actually like like to fly this thing, you just need to fill up your flight plan. You can do this 20 minutes before you fly. You do it on your iPad, you fill it up, you jump, the weather is good, you fly. And this is why people love it. It's cheap. Yeah. And if you don't have to go to an international airport, you don't have to go through security checks, and stuff like that. You fly VFR, you don't fly IFR, so you don't need to wait for any clearances or something. So they will just like, you don't fly through the biggest airports, or if you have an ego, you can ask, and sometimes they will let you. They let us do the low pass in Vienna International during the day.
Yeah.
So it was fun.
So
Tell me.
this is the max, like fully fitted out dashboard,
Exactly.
right?
You have the thing with the dashboard is that it seems that it's filled up because you have a lot of displays, but the thing is that there's physical instruments, and there behind the instruments on a pricing on a spec sheet you can see a little R. That means the instrument is remote. So for example, this airplane has 2 radios, and you control these 2 radios. They're hidden behind the panel, and you control them through the interface, through the touch screen. So that's the thing. Then this plane has a traffic viewer, and it's like also remote unit which sees the airplanes around you, so you can visualize. You can see, like when we're flying tomorrow, I can show you that above us is flying Emirates 29er Heavy to Dubai. You can see their heading, their altitude, and stuff like that. It gives you warning if there's an airplane in front of you. If there's, and this is the good thing, if there's a glider somewhere, you're flying over the mountains, there's a glider, you're so fast. The glider is doing 75 kilometers in a turn, and you're flying there at 300 something, 330, 350. So before you see the glider, it might be a collision or something. And if the tower, if you're not speaking to anybody on the tower, like or on an informational service, the systems that we use, they basically communicate through the satellite. And if you have a glider and it has even like some smallest GPS on board, like the radio with the GPS, and every glider has this, this will communicate and with the satellite, and it will start to give you the warning because it sees the traffic in front of you.
Wow.
So it will
That's
give you
amazing.
traffic, and sometimes it will visualize the traffic even if the glider has non-certified navigation.
Wow.
So it's different than TCAS, because TCAS only you can only see aircraft which give a signal.
Yeah.
But this is everything.
Yeah. We're now standing in lamination and composite department of JMB Aircraft. This is where we make the whole technical structure of the aircraft, such as wing, the fuselages, the tail parts, the inner sides. The VL3 is completed from about 250 composite parts, which is a lot of them. And of course, you need to be as light as possible because, as I said previously, because of the regulations. So the main 3 materials that we work with is a pre-preg, it's a carbon, and it's a glass fiber. All right? Lamination and the composite materials are basically, if for people that are not from the industry, you can imagine it like if you're cooking lasagna. All right? So you're cooking lasagna and it's a layers, and between the layers there's something that connects the layers. But we don't use a ketchup like you do in lasagna, but we use a resin and a glue. So basically there's a huge and massive work behind each composite part, where you work that you will put, like you have a mold in the beginning. So that's if you cook a cake. So you need the part to get some certain shape. So you have molds. Those are the things all around us. We have molds for the wings. We have the molds for the fuselages. And then you basically start to put the layers of carbon between, there you go, resin. There's another layer of carbon. There's another layer of resin. And then basically when your part is finished, you heat up the part for a certain temperature. Like every part is made with different temperatures, with different requirements. And then this is all you know from the Airbus, how they make a composite parts. This is pretty much the same way. They use a little bit different technology, which I will show you also, because the technology that we use to create the VL3 is called the wet lamination. And basically wet lamination means that you're doing all the parts by hand. There's another type of lamination, which is called pre-preg. And this is basically the lamination where you don't have the rolls like this. You get them packed in a foil, and they're already soaked with resin. You need to keep them in about minus 20, 25 degrees Celsius. They have expiration date. Like these, with wet lamination, these rolls, they don't have an expiration date. So you can work with them for a long time, because you add the resin later in a process. They're not soaked with resin. Also, how we get the resin in everywhere, because you need everywhere the same layer of resin, and you need as few resin as possible, so the part is as light as possible. So that's, you can see that the carbon fiber, it has a little holes in between. So there's always going to be resin that can enter the spaces in between the carbon. And then when you're finished with production of the part, then basically you have the same layer, and the part is extremely light and extremely strong.
How many layers do you need for all the parts?
So with the pre-preg, it's 6 or 12. With lamination of a VL3, it can vary. It can be from, let's say, 4 to 5 layers until 20 to 25, depends on what you want to do. I can show you that, for example, on a wing, if you want to join me. So there's a closed mold of a wing. Inside this mold, there's a finished wing, all right? This is bluish because it's a glass fiber, and the glass fiber is connected by the resin, and the resin is blue. That's why you get like a blue sense of the material. So and this is carbon. So when you have a wing, and so basically the whole wing is made with glass fiber.
Okay.
And this we use because glass fiber is a little bit flexible, as I mentioned before. So that's the turbulence is a big issue with an airplanes. When you have it like this, then you don't have an issue with it. Because
is it related to the fatigue life as well?
There's no limitation on a life. Like there's basically, you can see the gliders that has been produced 35 years ago. They're full composite, and there's no problem with it. The only thing that can hurt the composite is a heavy crash. So that's how you will damage a composite part. Or if you heat it up to over temperature. That's why a lot of planes that you see all around, and they're made from composites, are white, because the white will deflect the light, the sunlight. So that's why they are not heated up. And because of the special mixture that we use, our planes can be painted in dark colors, because even if they attract the light, which means the heat, we are basically able to. They can withstand like forever. Like you will much likely get damaged paint rather than like damage the composite part that the paint is on. So that's how we use it. Then we use the carbon, and I want to show you why and where we use the carbon. So this is half of the fuselage that is in a process, and right now. It's a full cover. It's a full carbon under this. All right, the fuselage is full carbon, and then what we do is that I told you previously. There's a little holes between the carbon, and we need to try to get as much resin out of it as possible. But there needs to stay some. So what we do is that when we laminate the fuselage into the mold, so we put the carbon layers and everything, we put like this fiber around it. And that's like freely sitting on the fuselage. We close it with the plastic, and there's created vacuum. Wow. Because the vacuum will try to get all the resin into this white thing. It will soak in the extra resin that is not needed. So everywhere is the same layer. And then when we tear the plastic off, well, we will just take these things off, the white stuff, which will be soaked with resin. And then basically we have extremely light fuselage.
Right, you've minimized the amount of resin.
Exactly, minimize the amount of resin. Then when this is off, we glue the two parts of the fuselages, and you get to something like this. And now you will hit me with a question. Hey, you told me that it's full carbon, but I see that there's a gold Kevlar in it.
Yes.
All right, because we add the Kevlar a little bit later in the process. But if you will see Kevlar everywhere where there's something that you can touch with your body. So you know Formula 1 racing. When a Formula 1 goes and it smashes to the wall, and it has a carbon diffuser. Yes. All right, you see a ton of sharp pieces flying all around. Mm-hmm. And this is like the whole fuselage is made from carbon. But if you put a layer of Kevlar in it, the Kevlar, it doesn't break into sharp pieces, but it bends. That's why you use it in ballistic vests, because it just doesn't go into sharp pieces. So everything which can touch your body, this is where you're sitting, this is your backrest, this is the cargo bay, this is where your feet comes. It's all covered in Kevlar. So if you have a crash in a VL3, it will bend. It will not cut you in half. But the tail is another story. We don't care about the tail. That's too far from us. So if you look behind this wall, you will see only carbon. There's no Kevlar. It would just add a weight. It's not needed. So, and we don't care if you smash the plane, you put it on a parachute, you do a parachute landing into the trees, you break your tail. Okay, it's a sad story. You lose the aircraft, but you will be always safe because you're inside. covered all around in Kevlar, so there is nothing sharp that could reach out to your body.
All right.
So that's how we use it.
How do you fuse the two sides together? Do you overlap them again, or is it just?
There's a resin and a glue. The beauty of the composite work is that basically, if you weld two metal things together, if I would do like two metal bars like this, and I would start to push, they will try to break in a place where we welded them, because there's the structure of the material is the weakest. Not with composites. With composites, you can up laminate, and the whole structure will be as same as possible, even if you add the another layer months later.
Okay.
So this is a beauty. You just need to follow the process, heat it up again, and then it will get the same structure. So that's the beauty of composite. That's the thing, is that it's a huge work to fix the aircraft that has been crashed, but it's absolutely doable. So it's just more hours, but it will be doable. It will be strong as it has been before. But when you fix the broken aircraft, you will always add, of course, a little bit of weight, like 1 kilo, because you will need to add a little bit more glue, a little bit more resin. But then when you have a fixed broken plane, it will, from the force or strengthness point of view, it will be as same as it was when it was produced brand new.
And so you talked about crashworthiness with the Kevlar. Is there any padding you guys put on the bottom as well?
No, there's no padding. There's basically, you're sitting in this area. There's another like seating positions, like seating bars under you, and here you immediately have installed the landing gear.
Oh, the landing
yeah,
gear.
the landing gear system, and the landing gear, it closes and it's in one point. There's if you think about it from the technical point, how much things we have inside of the plane, then it's like, and it's all handmade.
Yeah.
It's truly amazing that everything fits. And if you look at the gear, extended gear of a VL3 sitting on the ground, and you'll be like, where the hell does it go? And where do you fit the people? And to be honest, it's actually very comfortable to travel in a plane. So we made it like really user friendly. Where we're standing here, we call it a big parts lamination, all right? We're speaking about the wings, we're speaking about the fuselages and about the biggest part. We try to save the weight, then I'll show you the open wing, for example. So for the wings, for example, the VL3 doesn't have the actual fuel tanks, because we use that's called a wet wing fuel technology, and this is your fuel tank. This is going to be it. There's not going to be a metal fuel tank inside. We just put a special fuel resistant layer on here. We'll close the wing, pressurize it, test it to 2.5 atmospheres. If it doesn't leak, it will never leak again in life, because it will never move or something like that. It's a funny story, because if you have like it's a SR72 is the fastest 71 yeah, sorry, 71. So they also needed to save the weight, because the airplane was so much heavy, so they used the same technology.
It was leaking, right?
Exactly. And you could and you were measuring the drops per minute, and if it was like less than 30, you could go there and go up there. So ours are not leaking, but that was a metal plane. But it's the same technology, basically.
Because the composite doesn't really expand that much in the heat.
No. That doesn't expand. The only problem that you could have is that the fuel pumps are very strong in a VL3, because you need to. It's a turbo engine. It's a injection engine, and the fuel pumps really need to feed it with the fuel under high pressure. So they are taking a lot of fuel, let's say, from the tank. And you need to get the air inside the tank, so there's like no compression. So there's like an intake for the air, and there's a tube which will go until the end of the wing, and there's an air intake. And if this gets stuck, then basically you will start to get the warning there's something bad with the fuel tank. And the upper side of a fuel tank, it can go a little bit tilted in the, to inside. This is not anything like dangerous or something like that. It happened out of 700 units. We saw it on 2 planes. But basically the guys, when you do the pre-flight, that's why we use the checklist. You check your oil, you check a lot of stuff on the aircraft. And also one of the points is that you go to the end of the wing and you physically check if the inlet for the air is free or not. So that's it. When you have a dirt in a tank or something, you put you do the wrong oil. There's a rust in it or something. there's several systems which will stop it. There's one filter, like immediately inside the plane, which is like you can even wash the filter, you can exchange it.
Okay.
And there's another one directly on the head of the engine when you're spraying. So
Make sure it's clean as possible.
yeah, so you should not like damage your engine if you really take like a really bad fuel. So right now we're in a small parts lamination. This is where the actual magic happens, because here we're extremely sensitive about the weight. The huge wing, it's pretty much possible to control the weight. You immediately know if something is bad. But here you need to be much more sensitive about the weight. The parts are very small, they're extremely light, but here you can gain a big numbers in a total if you're producing overweight parts. So we need to check the weight, and we also need to check the quality in here. And we were thinking how to do this, like Jean-Marie, our CEO, his initial idea was like, I need to employ 60 professionals, all right? Absolute professionals who know what they're doing and stuff like that. In the end, you find out that this doesn't make a financial sense, because these people need to be like hugely paid. So Jean-Marie was thinking about it, and he was like, all right, let's take it another way around. Let's take the processes and let's have an extremely professional quality control. Let's do it as easy as possible, so we immediately know if the part is good or if the part is bad. And I'm going to show you what we figured out and how we work with it. When we produce any kind of part, the worker will scan a code, and there's basically in this is written like everything. This is how much you need for certain stuff. It gives you like centimeters square of glass fiber, of Kevlar, of carbon. It tells you how much epoxy and glue you should make a mixture with, and we make a mixture. So this is what we don't have written. The mixture is our know-how a little bit. So they have like only here written the mixture for the certain part. We don't, because this part will be not exposed to the sun or something. So there's maybe a little bit amount of glue.
What kind of parts are we like talking about?
We are talking about the inner parts. We are talking about the connection bars in the wings. We're talking about the connection parts under your sitting, and everything what you see inside. Everything excluded the big parts as a fuselage and as a wings. But like the support bars inside and stuff like that. And how we control the part is produced, and we also need to measure how much people are working on a part, so we can really know how much the production takes. Mm-hmm. So they will start the operation, they will scan themselves in a system, they will have exactly the material that they need for the part. Of course, if they need a little bit more, that's an indication that something is not going right, because this has been produced like this. And then when they have all the material on the table, the mixture of the resin, the mixture of the glue, the certain amount of the composite material, and they start to work on it, mm-hmm. What they do is that they have these little things, and they will put a drop inside of the mixture that they did. All right, they have it like in a small can. They will put a little drop inside here, and then they start to work. They don't care about anything, and they just follow the procedure which is here. And then in the end of the process, the quality controller will come and see the sample. And if the sample is still liquid until a certain amount of time, mm-hmm. There was a bad mixture of a glue and a resin.
Okay.
And he knows that this part made by this person needs to be trashed. So the wrong part can never go through.
What's the so you show the materials list, the bill of materials. Mm-hmm. What's the I forgot the word. Like the space, like the margin for error, yes.
Margin, so for small parts, we are speaking about grams. And for example, if you have a part like this, this seems like a gear door, I strongly believe. So the elevation on this would be between 3 to 5 grams. If it's more,
this would weigh like 200, 300 grams.
There's going to be written how much it can weigh. So they will, or the quality controller has it. So there's for each. So they will weight it. If it's overweight, we have to throw it out. So the production of a VL3 consists of big parts lamination, small parts lamination, rough assembly, and finishing, and final assembly. So those are like 3 spaces. We started at big parts lamination. Now we're in small parts. I'll take you to rough assembly. That's where you brush everything together so it fits perfectly, because all plane, even though they look the same, they're a little bit different. So there we fit everything together, and when it's fitted and perfected, it goes to the finishing where we can paint it. And that's where we're sure that we're assembling the plane that has like the same leading edge everywhere, that connects with the fuselage, the wings, and stuff like that. So this is the magic behind it.
Is Kevlar also used in these smaller parts, or is that only for the bigger parts?
Very few. This is like the Kevlar takes on a lot of resin. So we use here mostly the glass fiber and the carbon. Yeah. So we're now in rough assembly, and this is basically the place where all the composite parts go together, and we're fitting the wings on the airplanes. We're making sure everything is connected in a straight line, and we're putting, this is the place for the parachute ropes. This is where they're connected. So under this, there's already a rope from the parachute. There's a laminated little tunnel. We'll cover this. The parachute is, when it's shooting out in case of emergency, the ropes need to get out easily. So that's why there's this. There's basically going to be just a layer of filling, and then we're going to paint it. So it's not fragile, not at all. You will never see it in the future, like if you would. Yeah, but when you pull the parachute, it goes like here. When you pull it out, when you shoot the Patrona, so the ropes will get out easily. They stay clear out of the cabin, so you're safe. Nothing will hurt you. Yeah, exactly. And you just stay inside of the aircraft until you're on the ground.
This is different to the Cirrus, right? The Cirrus has it here on top.
Exactly. So we had we didn't want to be too much back, because if we would put the parachute in here in this area, we would basically lose the space for the cargo, which is also like, it's a travel fast plane, so you need to put the cargo in it. So we wanted to keep this space free so you can put your suitcases and stuff like that. And here it would be too far from the center of the gravity of the plane. So there you would, the connection would be like kind of different. You would need to bring the ropes like somewhere here. So we just did it in the front, and it's all about the CG. We all played it. So you have a heavy engine in the front, you have quite a heavy parachute in the front, and then basically your CG is somewhere under your knees if you're sitting in it, so somewhere around here. And basically, that's how heavy all the front is. And because, for example, if I would put 1 kilo of the weight on a tail, I need to add 4 kilos on a front. Yeah. Because this is a big lever from the physical. Like this is a big lever. So that's always about the CG. Always about this. It's always about the hassle.
And it's also with like rockets, right?
Yes, it's a rocket. It's a rocket. We tested it once in front of the factory. The company was like showing us their new parachute certified for higher maximum takeoff weight. So we took an old fuselage. We did like 10 and 9, 8, and it was like, I was shocked how fast it went and how far it went. And literally, we shoot it out, and it really opened. The parachute actually opened, and the plane was like this. It was static on a field. Okay. So it's really working.
Awesome. How many of those do you make a week in this building?
The fuselages? Yeah. So we should be like, we always need to be in a contrast of, we need to produce as much as we sell. So it makes financial sense. We're able to be faster with the fuselages. So we should be doing about 1.6, 1.7 fuselages in a week. Okay. If we want to produce 70 aircrafts in a year. We can go slower, we can go faster.
In this department, how many people work here?
In this department, I think there's going to be just 15 guys, but in a whole JMB aircraft, there's going to be 165, 175-ish people. Yeah. If you imagine that we're producing 4 types of airplanes with 165-ish people, that's truly amazing.
Very impressive, yeah.
So I showed you the nice marketing side of a design room, which is like for the customers and everything, where you design it, the interior. But now we're sitting in a place where we actually do the interiors. It's we have everything in house. We create them right here on a spot. We use different foams. You can specify if you want like very comfy seats, or if you don't want the comfy seats. So basically, like all the interiors of a VL3, they're hand sewed. So basically, you have the structure, the seat from the Kevlar and like the mesh material, and then we glue the leather on it and we sew everything together. So this is the seat in the middle of the process. You can see the imperfections, but when they're ready with it, like finished with it, then basically it will look like a serial production seat. And there's 3 ladies doing all the interiors for the VL3s, the side pockets, the central tunnel, the seating. So this is where the magic happened.
The customer gets to decide the colors and
Of course.
Even the pattern of the seat?
Yes, of course. We have different patterns. So these are the seats that for some reason they will never be used, and these are the different designs. So we have different lines of the seats. We can do the seats that match your exterior. And basically, when somebody will select a certain design of the seat, the ladies here, they know what to do, and they will be like, okay, so we have this seat, this is the scheme that we have to follow, for example, the lines and stuff like that, but the customer decided that this will be Alcantara, this will be leather, and the stitching will be black, and I don't know, and there will be a red line. But they follow the same scheme. Okay. So, but it's fully customizable. So the seats can literally look different. If you look at this seat, then this seat will remind you of these are the sextagons that you saw for the 916. So you can get this seat only if you have an engine from Rotax with a 916 with a 160 horsepower, and it matches the exterior colors. Yeah. So that's what we do. All right, so now I took you guys to the hall where we produce the Evo 4-seater. So this is the addition to JMB Aircraft airplane family, and this is where the big things happen. So behind me there's 2 fuselages that are going to finishing department. So it's the same process as in a VL3, but this aircraft can cruise in 28,000 feet. It's a full pressurized cabin, full IFR, also retractable gear. You'll be seeing some speeds around 300 knots when you're cruising there. And right next to me, this is a Pratt & Whitney PT6 producing 750 horsepower. This is kind of fun to get them because the PT6 you can order from Pratt & Whitney, and we are small manufacturer, so they produce the 1,000 units in a year of this variant. You have 850 horsepower variant, you can go higher, but this is the perfect match between the engine and the airframe. And I always say to my boss, when I quit, I will come here in the evening with a truck, because this engine is $500,000 today. So this is
one VL3.
It's a little bit more than one VL3 actually. Yeah. So we have the second unit is somewhere behind us, and for next year we have ordered 4 units for about 2.3, 2.4 million USD, and that's the biggest amount of we can get. So we're not limited by anything else than the engine's availability. Also behind me there's the Evos. When we spoke about the producing of a VL3, we spoke about the wet lamination. So this is a little bit different type of lamination. This is made from pre-preg, which if you have very good skilled hands, this is easier than the wet lamination, because this is made from the layers that are already soaked with resin. You will take the roll of a pre-preg, which is basically the roll of a carbon, out of the freezer, and then you need to work with it because it's going to be a little bit sticky because of the resin. But everywhere you have the same layer of resin, you will start to put this onto the layers, and then you heat it up, as I said with a VL3. But there's a difference that like pre-preg is heated up until much higher temperatures. So this is exactly the technology that Airbus is using for their fuselages and stuff like that. You hear that it's a composite fuselage from Airbus, that's why it's light and stuff like that. So this is exactly the same technology. So this is how they create the doors for the doors for the Airbuses and stuff like that. Because there's they couldn't do it with a wet lamination, because sometimes if you have a Airbus flying into Cape Town to very hot weather, then you're flying to Norway where it's very cold. So the differences between the temperatures are in such a short time frame and such big that it would not withstand. You'll be flying, yeah, you'll be flying up there in -45 degrees Celsius. Celsius, and then you're landing in plus 40, for example, you know? So this would be too much for the material. But for pre-preg, this is not a problem, because the pre-preg is heated up to 150 degrees Celsius. You can do even more. And then you can see even like the private jets that are made with the pre-preg components, they're painted full black. You can see the Gulfstreams that are full black. So they're made like they're made for combination. It's a metal, and they have a combination of like pre-preg parts that are heated until higher temperatures, because you will never cross like, let's say, 100 degrees Celsius even on a sun.
All right, amazing.
Thank you very much.
Pleasure.